Okay, so today we're going to be learning about inverse functions. And inverse functions should be a little bit familiar. You've done them a couple of times now. I know when we went over them in class, those of you that were there, like it wasn't completely mind-blowing. So let's just kind of establish what an inverse function is. So we know a regular function has there's exactly one input for an output. Well, an inverse function, first of all, is a function, but it is a function where the output becomes the input and the input becomes the output. So basically all that's saying in English is that the x and the y values are switching spots. So we have this diagram here where a traditional function is going to map an x from the domain to f of x, which is the output. So in a normal function, this is what's happening. It's going from here to here. So basically what that means is if I plug in a number for x, I'm going to get a number in f of x. But in an inverse function, it goes the other way. If I plug in a number for f of x, I'm going to get my x value. So this is the inverse function. So this is what the inverse function does. So that is how they're different. So typically, the x is determining the y, but in an inverse function, the y is determining the x. Okay, so that's how they're different. And how we say that is if f of a, so that means if I plug in a number a, I'm going to get b. Then in the inverse function, if I plug in that same number, that output b, I am going to get a. It goes backwards. So let's go into an example. In this first one, hey, Julia, we'll read later, okay? Hold on. So assume that f is 1 to 1. We're going to evaluate. So first of all, just kind of backstory, it has to be 1 to 1 in order for you to evaluate a function. So remember, that means that each input has one output and each output has one input. So if we're given f of 3 equals 2, we need to find f inverse of 2. Well, going back up here, this is giving us our a and our b. So then f inverse of 2, well, the 2 represents the b value. And I know in the inverse function, f inverse of b is equal to a, which means here, if b is 2, then the f inverse of 2 has to equal 3. It's just going backwards. So if this, it's basically saying that if this is the output, then it's going to determine the input 3. So all I did was really swap the 2 and the 3. That's what an inverse function does. It says that the output is now the input. Okay, so let's look at this one. On this one, it's careful to note that we're actually given the inverse function, which means that we're actually given the terms like this. We're given f inverse of b is equal to a. So in this case, the b is the -2 and the a is the -1. And we want to find out what f inverse of -1 is, which is what is the f of a. What does f of a determine? Well, remember, f of a determines b, and f inverse of b is -2. So f of -1 is just going to be 2. So that's how this is, or sorry, just probably -2 since that's what we're actually given. So I'm not pulling these numbers out of anywhere. They're actually right here. And all they're doing is switching spots. So that's kind of an easy example. You can also do this with tables. I'm not going to go over tables. I actually decided to go over graphs because we have a little bit of a harder time with graphs. So in this example, we're going to start with just identifying g of 1. And so going back to your notes on 1.1, g of 1 just means that we're finding the output when x is 1. That's what we're doing. So if I look over here, x is 1. The output is -1. So I'm going to actually mark that up in a color. So this is going to give me g of 1. Okay, so that is g of 1. So g of 1 is -1. Okay, Next, I have to find g of x equals 1. So remember, this is trying to find the x value when the output is 1. So looking, 1 is right here, output's right there. Oops, I wanted to use my drawing tool, sorry. Right there. So that means that this is g of x equals 1, which is 3. So then we're going to say g of 3 equals 1. And again, that's just because when x is 3, the output's 1. And that's really all that we're trying to find here. So now I have to find g inverse of 1. Now I have two different ones here. Okay? But if I look, g inverse of 1, I'm looking for when the output is 1. And in equation B, the output is 1. So g inverse of 1 has to match the input there. So g inverse of 1, well, when the output was 1, the input was 3, so g inverse of 1 is going to equal 3. And again, it has to come with the fact that I know the inverse function is evaluating when the output is 1, and the output is 1 on B. So we're going to just take the a value from that function, which was 3. So now we're going to solve for g inverse of x, and we're looking for when I evaluate the inverse of x, the output is 1. So remember so again, this is all backwards because it's the inverse function. In the inverse function, the output's actually the input, right? So now we're looking when the input was 1. Well, when we found the input was 1, that was in the first equation in A, when we had g of 1 was negative 1. So in g inverse, when the output is 1, the input is going to be negative 1. So these two are tied together. So then the g, I put the right thing, g inverse of negative 1 equals 1. And again, this comes from A. So it's just a little bit of like backwards thinking. But these two, A and D, go together, and B and G, C go together. Okay. So once you have this, you can do the same thing with tables. But remember, tables are going to be a little bit easier just because you're switching the x and y values. But we're going to look at how to find inverse functions, because inverse functions are going to be really helpful. One thing that we know about inverse functions is that when they're multiplied together, it cancels out. You get 1. So that's what's kind of cool about the inverse function. So we have some steps. The first step is you're going to replace y for f of x. And then you're going to switch the x and y values. You're going to solve for y. And then your final answer, replace y for f inverse of x, and then you're done. So let's put that into practice. Here we're going to find f inverse of x. And the first one I'm given is f of x equals x plus 5. So I'm going to follow that first step, step 1. I am going to replace y for f of x. So it's just y equals x plus 5. All right, now that I did that, I'm going to move on to step 2. I'm going to switch x and y. So now instead I'm going to have x equals y plus 5. And here, we'll even write the steps. How does that sound? Because I know some of you really like your steps. Me too. All right, so step 3, I'm now going to solve for y. So when I'm solving for y, I'm doing inverse operations. So I'm just going to subtract 5 from both sides. Subtract 5. Put it right there. When I subtract 5 on the right, it cancels. Boom. So then I'm left with, what are we left with? Oh my lord. Oh my lord. We're left with, on step 3, oh my gosh, stop being dumb. Nope. I hate it when my computer thinks it's smarter than me. It's not. All right. Okay, this is bothering me a lot. Anyways, I'm gonna give up. So step 3, we solve for y. We have that y equals x minus 5. You could also have x minus 5 equals y. They're both the same thing. It really hates me. Okay. And then step 4, we're going to replace y for f of x, and then we're done. So step 4. So then 4. I forgot I have to use that stupid tool again. I obviously prefer paper, but it's fine. So then we have f, oops, wrong one. F inverse of x equals x minus 5. And then you're done. So that was kind of cool. So it was pretty easy, right? We replaced y with x, f of x, replaced x and y, solved for y, bada bing, bada boom. That is our answer. That is the inverse function. So let's try another one. This one is a 2-step equation. So let's just use those exact same steps again. So we'll start with number 1. Replace y with f of x. So we have y equals 9 plus 10x. Done. Step 2. What is that same color? That nice little purple color. I'm replacing x and y. So we're going to have x equals 9 plus 10y. Step 3, we're getting into some math. We're going to start solving. Step 3, I need to start by subtracting 9 from both sides. And this one's going to have a few more steps. I'm going to just subtract 9 first. 9. Subtract 9. When I do that, I'm going to have 2x minus 9 equals 10y, but we're not done. Remember, last time I was just able to subtract and call it a day. I can't do that right here. I still have one more step. I have to divide both sides by 10. Remember, when I divide both sides by 10, I'm dividing everything by 10. So divide. I'm just going to put 10 under here. 10. 10. And because I like fractions, you guys all know, I'm just going to leave it as a mega fraction. So I'm going to have, we're still working on step 3, remember, which was solving for y. So when I get my mega fraction, I'm going to have 2x minus 9 in the numerator, and then just 10 in the denominator, and that is equal to y. So then for my final answer, I'm replacing y with f of x. Remember, that's step 4. So instead, I'm going to have the same thing, 2x minus 9 in the numerator over 10 equals f inverse of x. Oops, right here. And that's done. That is all you got to do. So that is how we find the inverse function from an equation. And all of your problems, like I took all of your examples today from your notes, so these should be very similar. So you should be able to get the homework problems done. Obviously, if you have questions, please let me know, but we are going to be taking a quiz on Monday. Work with your groups tomorrow. Everything's going to be okay.